Okay, friends, this is fifth lecture, I think, on the sequence. So, the name of this paper is the real analysis. So, this paper includes sequence and series. Today, we have to complete the sequence. So, see now, next type of sequence is the Cauchy sequence. Okay, that is. I think we are completed up to this that is bounded sequences. Now see the Cauchy sequence. So Sn be a sequence of real numbers. See now Sn be a sequence of real numbers. Then sequence Sn is called a Cauchy sequence if for given epsilon greater than 0 there exists an integer n such that Sm minus Sn is less than epsilon. Okay, this is somewhat difficult. Looking to be difficult, it is actually not difficult. What is this actually now? See, what is that if for given epsilon? म्हणजे आपल्याला नोटेशन वेगळे आले थोडा प्रॉब्लेम येतोय पण बघा फॉर गिवन एप्सिलॉन ग्रेटर दॅन 0 म्हणजे फॉर पॉझिटिव्ह रियल नंबर एप्सिलॉन देयर एक्झिस्ट n means belongs to I means set of integers such that the difference between the terms Sm minus Sn is less than epsilon. Means what now? See. So let me take an example. See here in this space. That's why I want to write this here. So the sequence 1 upon n. Now see sequence 1 upon n. You know this one because it is 1 by 2, 1 by 3 dot in this way. Now you can identify the first term, second term. Okay. Nth term, whatever that. Suppose we take 1000 term, that is 1 upon 1000. This 1000वी term आहे. Okay, and minus म्हणजे हे 2000वी term म्हणजे 1 upon 2000. Okay, and modulus of this is. See काय लिहिले बघा या सिक्वेन्स मधली 1000वी टर्म आणि 2000वी टर्म याचा डिफरन्स. Okay, so this difference is less than epsilon. See now, see what I am going to write. Sm minus Sn its modulus हे epsilon पेक्षा लहान पाहिजे. Okay, epsilon पेक्षा लहान पाहिजे म्हणजे आता काय तर बघा परत लिहितोय sequence 1 upon n means you know that what is that. So 1 by 2 1 upon 3 dot in this way. Okay, मग for capital N we choose 1000 suppose and epsilon we choose suppose 0.01. It is real number and positive number. Then for n, for this n that is 1 upon 1000 minus 1 upon 2000. This difference, what is the difference? This is 0.000001. This is 1 upon 2000 means you know that. So what is the difference between these two? This difference या दोन्हीतला फरक जो आहे तो या epsilon पेक्षा लहान असणार आहे. मग ज्या सिक्वेन्सच्या बाबतीत असं घडतं की काय जसा टर्म्स वाढत जातील तसा त्या दोन टर्म्स मधला डिफरन्स हा अगदी लहान होतो. अगदी लहान. ओके, म्हणजे epsilon म्हणजे 0.01 का घ्यायचं असं काही नाही. We can take 0.001, no problem. Okay, मग तो डिफरन्स त्या आपण जे चूज केलं एप्सिलॉन त्यापेक्षा लहान असेल तर त्या सिक्वेन्सला म्हणायचं Cauchy sequence. So sequence 1 upon n is a Cauchy sequence. Okay, now see here is Cauchy sequence. Okay, there is a theorem now. If a sequence of real numbers Sn converges, then sequence Sn is a Cauchy sequence. आपण आता जो सिक्वेन्स घेतला सिक्वेन्स 1 upon n. सिक्वेन्स 1 upon n जो आहे तो Cauchy सिक्वेन्स आहे आणि आपल्याला माहिती आहे की तो कॉन्वर्जंट सिक्वेन्स सुद्धा आहे. ओके, सो रिमेंबर द स्टेटमेंट ऑफ द थ्योरम. इफ अ सिक्वेन्स ऑफ रियल नंबर कन्वर्जेस देन द सिक्वेन्स Sn इज अ Cauchy सिक्वेन्स. सो कॉन्वर्जंट सिक्वेन्स असेल तर तो Cauchy असतो आणि प्रूफ छोटंसंच आहे पण एक्सप्लेन करतो. Sn be a convergent sequence of real numbers and limit of Sn is equal to L. Convergent म्हणजे limit of Sn is L. मग लिमिट ऑफ एस एन इज एल याचा अर्थ काय तर एस एन आणि एल मधला डिफरन्स जो आहे त्याचं मॉड्युलस हे एप्सिलॉन बाय 2 पेक्षा लहान आहे असं मानलं तर एस एम मायनस एस एन म्हणजे हे एप्सिलॉन बाय 2 हे एप्सिलॉन बाय 2 म्हणजे हे लेस दॅन एप्सिलॉन म्हणजे डिफरन्स बिटवीन द टर्म्स इज very small number. That's why that sequence is called a Cauchy sequence. The sequence convergent असेल तर तो Cauchy sequence असतो. This is statement of the theorem. Next theorem is here is every Cauchy sequence is convergent. That is, if Sn is a Cauchy sequence of real numbers, then Sn is convergent. The sequence convergent असेल तर तो Cauchy असतो आणि Cauchy असेल तरी सुद्धा तो convergent असतो. We are not going to explain the proof of this one. If you are interested, you can see the proof. Okay, because we are not spending the time to explain the proofs of the theorem. Okay, next theorem is if Sn is a Cauchy sequence of real numbers, then sequence Sn is bounded. मग तो Cauchy sequence असेल तर तो bounded असतो. आता Cauchy असेल तर इथं मॉड्युलस ऑफ Sm मायनस Sn इज लेस दॅन 1 म्हणजे एप्सिलॉन इज इक्वल टू 1 चूज केलंय. मग मॉड्युलस ऑफ Sm हे असं लिहिता येईल की मॉड्युलस ऑफ Sm मायनस Sn प्लस Sn. ओके, Sn मायनस केले प्लस केले which is less than equal to modulus of Sm minus Sn plus modulus of Sn. म्हणजे आपल्याला एक हे माहिती आहे की modulus of a plus b is less than equal to modulus of a plus modulus of b. याच्यावरून which is less than modulus of Sm minus Sn plus modulus of Sn. And modulus of Sm minus Sn is less than 1 because that is a Cauchy sequence. So value of this is 1, that is which is less than 1 plus modulus of Sn. याचा अर्थ काय होतो की modulus of Sm is less than something. ओके, म्हणजे काय तर modulus of a is less than 1 याचं मीनिंग काय असतं तर a is greater than -1 less than 1. ओके, so modulus of Sm is less than some number. Then we can from this we say that this sequence Sm is bounded below and bounded above also. That's why we say that is the bounded sequence. Okay. There is a one concept, summability of sequence. What is meant by the summability? Now see, definition is let Sn be a sequence of real numbers and suppose notation given sigma n is S1 plus S2 plus dot 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 plus Sn upon n. We shall say that sequence Sn is C1 summable to L if sequence converges to L. Which sequence? Sequence sigma n converges to L. हा जो सिग्मा n आहे म्हणजे तुमच्या लक्षात आलं असेल की सिग्मा 1 काय, सिग्मा 2 काय, सिग्मा 3 काय. ओके, म्हणजे सिग्मा 1 म्हणजे फक्त S1 upon 1, सिग्मा 2 म्हणजे S1 plus S2 upon 2, सिग्मा 3 म्हणजे S1 plus S2 plus S3 upon 3. आणि मग ह्या सिग्माचे जे व्हॅल्यू तयार होतात त्याच्यावरून एक सिक्वेन्स तयार होतो त्याला म्हणतोय आपण सिक्वेन्स सिग्मा n. तो जर कॉन्व्हर्जंट असेल तर आपण त्या सिक्वेन्स Sn ला म्हणतोय C1 समेबल टू L. ओके, सो सी नोट that is since sigma n is given, so sigma 1 means what, sigma 2, sigma 3 etc. is given. Sigma n is precisely the average of first n terms of the sequence sigma n. So there is one theorem. So every convergent sequence is C1 summable, and every convergent sequence is C1 summable. For if sequence Sn is a sequence of real numbers and limit of Sn is L, then limit of Sn is L C1 written in this way. Meaning of this is this sequence Sn is C1 summable to the limit L. Okay. Now see from this example you got the idea. That is what is meant by the C1 summability of the sequence. Prove that the sequence sequence Sn which is equal to -1 raised to n is C1 summable. Okay. So see now Sn means -1 raised to n म्हणजे nth term of the sequence. So we get this is in this way. Okay, sequence Sn is equal to dot 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 in this way. So what is sigma n? Sigma n is S1 plus S2 plus dot dot Sn upon n. मग S1 काय आहे ते टाका, S2 टाका. So we get S1 means -1, S2 means -1 square, S3 means -1 cube dot 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 -1 raised to n upon n. बघा -1 प्लस याची व्हॅल्यू 1 मिळते म्हणजे हे 0 येतं. म्हणजे इफ n is 246 dot 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 sigma n is 0 and if n is odd, that is 135, this is equal to this is -1 upon n clearly. Now see, what is the limit of sigma n as n tends to infinity? If 0, limit is 0. If -1 upon n as n tends to infinity, -1 upon n tends to 0. So limit of sigma n as n tends to infinity is equal to 0. Therefore, sequence sigma n tends to C1 summable to 0. Okay. So given sequence is C1 summable to 0. Next is here. See, sigma, prove that the sequence 1 0 1 0 1 0 is C1 summable. So given sequence is Sn is 1 0 1 0 1 0. Sigma n is this one. If n is 2 4 6, so we get n by 2 pairs. म्हणजे हे n टर्म्स आहेत पण पेअर केले म्हणजे अर्धे होतील. म्हणजे n by 2 pairs upon n म्हणजे 1 by 2. आता 1 plus 0 म्हणजे 1च, म्हणजे 1 plus 1 किती वेळा झालं तर n by 2 times, म्हणजे 1 into n by 2 upon n, so which is equal to 1 by 2. म्हणजे if n is even, then we get this one. If n is odd, 1 3 5 dot dot dot, हे n minus 1 by 2 pairs आणि एक आहे तसं राहील. म्हणजे n minus 1 by 2 plus that 1 divided by n. Simplifying we get n plus 1 upon 2n. May be written 1 by 2 plus 1 upon 2n. Here is 1 by 2 plus 1 upon n. And what is the limit of this is? Limit of this is that the limit of sigma n as n tends to infinity, 1 by 2 so 1 by 2 आहे तसं, 1 upon 2n चं limit 0. So limit of sigma n is 1 by 2. म्हणजे n इवन असू द्या किंवा ऑड असू द्या, सिग्मा n चं लिमिट हे 1 by 2 आहे. म्हणजे सिक्वेन्स सिग्मा n हा कन्वर्जंट आहे. And that's why sequence Sn is C1 summable to 1 by 2. I think 2 examples are sufficient. Here is the next example. You can study it. Okay. So see, there are so many examples here. So this is all about the sequence. This is all about sequence. So this is 10 to 15, I think 15 minutes lecture. It is sufficient. But next time we start the series, just we introduce there. That is what is meant by series. If u1, u2, un be infinite sequence of real numbers, then u1 plus u2 plus dot dot dot. म्हणजे सिक्वेन्स मधल्या टर्मची बेरीज केली, इन्फायनाइट टर्मची बेरीज केली तर जे तयार होतं, दॅट इज वी कॉल द series. Okay, it's called infinite series. So when we learn totally about the series in the next lecture, 6th lecture. So this is all for this sequence. Just we see 4 lectures were completed. The important concept that is Cauchy sequence here. Then bounded sequence. So what is important is what is meant by the sequence. Monotone sequence कशाला म्हणायचं, बाउंडेड सिक्वेन्स कशाला म्हणायचं, कन्वर्जंट कधी असतो, Cauchy सिक्वेन्स कधी असतो, आणि C1 समेबल. म्हणजे ह्या सिक्वेन्समध्ये एवढे महत्त्वाचे पॉईंट्स आहेत की सिक्वेन्स म्हणजे काय. आय विल रिपीट व्हॉट इज मीन बाय सिक्वेन्स. देन what is meant by the sequence bounded, that is bounded below, bounded above. Then monotonic sequence means monotonically increasing and monotonically decreasing. If the sequence is monotonically increasing as well as decreasing, then it is monotonic, we call it. Then Cauchy sequence and C1 summability of a sequence. These are the points included in this unit sequence. Okay, no more, it is sufficient. This is a small video, no problem. We take the next time, take the lecture number 6 on the series. Okay.